This lesson is an introduction to transformations, and it's also going to discuss translations, which is a specific type of transformation. So there's three specific types of transformations that we're going to talk about in Unit 1. It's going to be rotations, reflections, and translations. We're going to call our new figure that we get after a transformation has been performed our image. And the original figure, or where we start, is going to be called our pre-image. So those are the two terms that we're going to use to talk about our before picture and our after picture. All types of transformations that we're going to be talking about in this unit are isometries. The most important thing that I can stress is that these are rigid movements. So what that means to us is the relationship between the coordinates, or the relationship between the sides of these shapes that we're going to look at, always maintains the same shape, the same distance apart. So it's not going to go from a circle to a square. I'm going to maintain that same shape and that same relationship, and the size is also going to stay the same. So I'm not going to move from a small circle to a large circle. It's going to stay the same size from our pre-image to our image. And we're going to look at a couple examples. So if you look at this, my pre-image I drew in red, and my image I drew in green. There's a couple of things I need you to notice right off the bat. All of my pre-image points are just listed as A, B, and C. But my image points, in order for us to know just by looking at this picture that green is my image, is this prime notation. So looking at this picture, does the relationship that I see between A, B, and C on my pre-image maintain the same shape and the same length and the same relationship between A prime, B prime, and C prime? And in this case, it is an isometry because the size and shape of my pre-image maintains the same size and shape when I move to the image. And we're going to get to what type of transformation this is later in this unit. So here's a couple pictures. I'm going to step aside for a second so you can take a look. Out of these four pictures, there are only two that are considered to be isometries. If you look at A, so P is my pre-image, I would be my image. If I'm looking at A, moving from my pre-image to my image, this pentagon gets larger, so this one would not be considered an isometry because it's getting larger. It didn't maintain the same shape, it maintained the same shape, but it didn't maintain the same size. B, going from my pre-image to my image, nothing about this shape has changed except for how it is twisted. So I'm going to say that this is an isometry. Again, we're going to get into what type of transformation this is later in the unit. If you look at C, from my pre-image to my image, the circle that I started with gets smaller when I go to the image, so that does not count. And then D, all that happens is I turn it. So this one I would consider an isometry. So if you have any questions about these, make a note on the side of your notebook paper and let me know when you get back to class. All right, so I'm going to step aside again. The notation that we're going to be using, we did already talk about the prime notation to denote which points are the image points. But we are going to be using this arrow notation, which is going to be very important to us later on when we start writing different rules. So if you notice over here, this would be the arrow notation that I would use to say I've moved from triangle ABC to triangle A prime, B prime, C prime. So this would be my pre-image moving to the image. And you're going to see this pop up all the time now. All right, so now we're going to go straight into translations. Translations is like a slide. So I'm going to take one picture and it's going to look like I have just I'm going to take the picture and just slide it to the left, slide it to the right, up and down, or some type of combination of those translations. Alright, so I'm going to go from my pre-image to my image, and I'm going to figure out a way to use arrow notation to describe this movement here. I'm going to step to the side over here. I'm going to use, just in the sake of trying to figure this out, I'm going to use this top right corner. And since all I'm doing is sliding my picture, I have to associate this pre-image point with the same location on the image point. So if I'm using this top right corner, when I look at the image point, I also have to use the top right corner. So for us to write arrow notation, I'm going to try and figure out how I would move from this point here down to the image point. So my movement that I'm going to describe is this movement to the right and this movement down. So I'm going to think of this point here as x, y, because ultimately I want to be able to write a rule for my pre-image point that is going to map or translate all of these pre-image points to my image. And in order for me to do that, I need to make a generalized rule using x and y. So if I'm at x, y, or this top corner point right now, what movement am I going to do to end up at this point? So I need to look at two very specific things. I need to look at how the x value is going to change, and I need to look at how the y value is going to change. So x would be a horizontal movement, so I need to figure out how many spaces I have moved and in what direction. So because I'm moving to the right, I have to think I'm going from, in this case, -1 to +4. So I am adding units onto this x coordinate here. So I'm going to say x plus however many coordinates I'm moving. And that would be 5 units altogether if you count over. Now I have to do the same thing with y. Because I am moving down, I have to consider how I would do that mathematically. I'm starting at +4 for my y value, and I'm moving down to +1. That movement down would be subtraction. So I would write that as y minus 3. Now I have to put that into arrow notation. So I would start with my pre-image point. So I would start with x, y. The arrow tells me that I'm now moving to my image point. And I'm going to say that I'm doing x plus 5 and y minus 3. And this rule that I've written out in blue is going to show me exactly how I can move every point on this pre-image shape to every point on the image shape. And the last one that I'm going to leave you with is one that you're going to try on your own and bring back to class with you the next day. So I'm giving you vertices of A, B, and C on this triangle. And now I'm giving you the translation rule, the generalized rule that's going to help you with A, B, and C. And based on what I did on the last example, I want to see if you can do this translation without me. And this is the first problem that we're going to go over together in class tomorrow. If you have any questions about any of the information that I've done on the video, please make sure you make a note in your notebook and bring it to class with you tomorrow.